The efficiency and life of Rockwell on-highway products depend on proper oil and grease lubrication to reduce friction, help cool, and keep dirt and wear particles away from moving parts. Improper lubrication may be a major cause of component damage and wear. Hello, and welcome to Rockwell's Lubrication Update. This is a specially prepared program on lubrication and maintenance procedures for Rockwell axles and transmissions. In this program, we'll give you an overview on oil and grease lubricants. We'll look at related areas such as magnets and magnetic drain plugs, breathers, seals, and temperature indicators. And then we'll cover in detail the proper techniques in checking, draining, and replacing oil in axles and transmissions. But before we begin, it's important to remember that Rockwell has set standards that all lubricants must conform to. And this is because each component operates differently and requires a different lubricant. So make sure you always use the Rockwell Lubrication Manual. It includes recommended oil and grease lubricants, their specifications, capacities, and scheduled changes. Oil lubricants fall into three categories: petroleum, semi-synthetic, and full synthetic. Petroleum oil is derived from natural crude oil extracted from the ground. This crude oil also yields combustible fuels and a wide range of petrochemicals. Semi-synthetic oil contains a mixture of petroleum-based and 25% synthetic fluids that can extend service intervals, improve cold weather properties, and reduce volatility. But let me note here that semi-synthetic oil must not be used in Rockwell transmissions. A full synthetic oil uses a man-made base oil with predictable physical properties. No refined petroleum-based fluids are used in the base oil. Full synthetic oils slide better and boost lubricating and cooling performance, particularly in extreme temperatures. Also, there's less oxidation at high temperatures, which allows for extended drain intervals. Now, because synthetic and semi-synthetic oils maintain their lubrication properties longer, they played a pivotal role in the development of Rockwell's factory-filled advanced lube axles and transmissions. These advanced lube components, compatible with today's tough extended drain requirements, bypass the initial drop, resulting in fewer oil changes and lower cost to operators. Fewer changes also means less oil placed in the environment. Factory-filled advanced lube axles with full synthetic oil can go as long as 500,000 miles before needing a change. Advanced lube transmissions with full synthetic oil can go 250,000 miles before needing an oil change. All right, now let's look at other properties significant to oil lubricants. Proper viscosity is the measure of the oil's ability to flow and is very important to understand when selecting an oil for a specific Rockwell component. When more than one oil is listed in Rockwell's recommended lubricants chart, always use an oil viscosity suitable for the expected outside temperature. Oil lubricant viscosity grades are classified by the Society of Automotive Engineers, or the SAE, and their service classifications by the American Petroleum Institute, the API. Multi-grade oils must be used between oil changes when vehicles operate in both cold and warm weather and cannot be used in transmissions. Low viscosity single-grade oils are used only in cold climates where no warm weather is ever forecast. Single-grade 75-weight oils are not approved for use in drive axles where temperatures exceed plus 40 degrees Fahrenheit. One important point: never use thinning agents such as kerosene, gasoline, or any other dilutants to lower the viscosity of recommended lubricants. Rockwell drive axles have hypoid generoid gearing that requires oil with extreme pressure additives to provide adequate lubricant film protection that reduces wear. EP lubricants contain special additives that provide extra anti-wear protection to heavily loaded parts. Rockwell requires EP oil or EP grease in various applications. Approved hypoid gear oils contain EP additives that protect against gear tooth scoring. You should also make sure you consider the reputation of refiners or vendors when selecting an oil lubricant. They are responsible for the quality and correct application of their products, and in all cases, assume all responsibility for the performance and longevity of their products and for product and patent liability. There are many practical reasons for recommended oil changes. Draining and refilling with a fresh supply of oil helps to assure the quality performance of Rockwell components for our customers. Oils not only lubricate, they provide chemically reactive additives, wash away minute wear particles, reduce noise, inhibit corrosion, and transfer heat. A regular scheduled oil change for a particular component can be determined by analyzing oil samples taken at specified intervals or mileage. However, the final recommended schedule may be due to the truck's service duty, regardless of the vehicle's mileage or an established change schedule. Grease lubricants that are typically used to keep metal-to-metal parts moving contain three major components: oil, a thickener base, and additives. The oil acts to lubricate. The thickener holds the oil in place and releases it to provide the necessary lubrication. And the additives enhance the characteristics of the oil and thickener. Extreme pressure additives, for example, help prevent scoring, galling, and welding of moving parts. The thickener base may be a simple or complex soap that is organic or inorganic. It determines the grease's major properties, uses, and its compatibility with other types of grease lubricants. Also, be aware that mixing incompatible greases may result in excessive softening or hardening and seriously reduce the lubricating ability of the recommended grease. A very important property of grease is its dropping point, the temperature where it changes from a semi-solid state to a liquid state. However, the operating temperature of a specific grease is not determined solely by the dropping point. Other properties, such as the grease's resistance to change in thickness and chemical breakdown at high temperatures, must be considered. Grease lubricants are classified by the National Lubricating Grease Institute, the NLGI, and given grade numbers based on the consistency of the grease. Recently, NLGI has instituted a new specification and classification system for automotive greases based on application. NLGI issues license symbols designating the application for which the grease is approved. Always use Rockwell recommended grease products and change intervals to ensure proper component performance. Operating any drive axle or transmission generates small metallic wear particles, especially during the break-in period. If these fine but hard particles are allowed to circulate in the oil lubricant, along with external moisture and dirt, internal components, as well as the oil, will break down at a faster rate than normal. To collect the damaging particles, Rockwell drive axles and transmissions are equipped with magnets and magnetic fill and drain plugs with a minimum pickup capacity of 1.5 pounds each of low-carbon steel. Also, since there is no initial drain for the advanced lube axles and transmissions, the need is greater to keep damaging debris from circulating throughout the lubricant. To satisfy this need, Rockwell increased cleaning procedures within the manufacturing process to build cleaner components. Advanced lube axles are equipped with a series of powerful 5-pound pull magnets and higher grade magnetic fill and drain plugs to capture any metallic debris generated during the crucial break-in period and extended drain interval. Rockwell magnets are stronger than those of its competitors. In this demonstration, one Rockwell magnet picked up 13.2 grams from 15 grams of metallic particles suspended in oil. The competitor's magnet picked up only 5.1 grams from the same amount of particles. And compared to one major axle supplier, Rockwell has twice as many magnets in tandems and 3 times as many in single drive axles. Tandem axles have 4 5-pound pull magnets mounted internally in each housing. Single axles have 6. Highly efficient breathers help keep Rockwell axles and transmissions free from external moisture and dirt, which can cause premature oil and component failure. In advanced lube axles, a more advanced breather design significantly increases the ability to keep the lubricant environment clean during the extended interval between oil changes. This breather's unique lower profile design has a sealed water barrier consisting of a secure Teflon O-ring, a coated stainless steel screen, and a layer of material that acts as a major barrier against contaminants while allowing air to circulate in and out of the housing. Seals keep lubricant in and dirt out of a component. When they're worn or damaged, seals leak and produce damaging low lubricant levels. Durable triple lip seals, standard in Rockwell axles and transmissions, protect the quality and levels of oil and provide superior performance between moving parts. Advanced Lube axle triple lip seals use a patented polymer to further improve seal performance. They meet the demands of the extended drain environment and are compatible with any approved lube. In seal durability testing against the competition seal material lasting 240 hours at 230 degrees Fahrenheit, Rockwell seals generated much less heat at lip shaft interface. The seals also retained radial load during competitive testing at 12% loss versus 65% loss, and retained seal lip interface of 1% loss versus 53% loss. And most important is to always use the correct tools and procedures when replacing seals. If the correct tools and procedures are not used, the seal can be installed incorrectly and leak. Although Rockwell axles and transmissions may operate above 190 degrees Fahrenheit, 88 Celsius, without damage, when the oil temperature reaches 250 degrees Fahrenheit, for no apparent reason, the vehicle must be stopped immediately and checked for the cause of overheating. Now, oil temperature in transmissions can reach 275 degrees Fahrenheit during a difficult climb. But what's important here is that the oil temperature goes down to normal less than 225 degrees Fahrenheit once the vehicle is back on level ground. If at that time the temperature does not fall or runs above normal, the transmission should be checked for the cause of overheating. Many Rockwell axles and all transmissions have a tapped hole in the housing for the installation of a temperature indicator. Monitoring the oil temperature will help reduce component damage and wear caused by overheating oil. The temperature indicator is particularly useful in through-drive tandem axles, where severe operating conditions and mismatched or unequally inflated tires may create an unacceptable rise in oil temperature. Oil coolers are used in Rockwell transmissions if the operating temperature is 225 degrees Fahrenheit, 107 Celsius, at continuous operation, or 250 degrees Fahrenheit, 121 Celsius, at intermittent operation. Transmission oil coolers are recommended if the engine has a horsepower rating of 350 or more, and they are required with 400 horsepower and above. Some aerodynamic vehicles may require a cooler at lower horsepower, and this is due to the reduced amount of air available to flow over the transmission to carry the heat away. Proper oil levels are important in the operation of axles and transmissions. When the oil level is too low, components may not receive the adequate amount of oil needed to reduce heat-generating friction between moving parts. When necessary, the oil level must be checked and adjusted accurately while the vehicle is parked on a level surface. Maintenance Manual Number 1 describes the correct lubrication procedures and most current specifications for Rockwell components. Be sure to follow your company's safety procedures when you service or repair equipment. Understand fully all the procedures and instructions before you begin work on any unit, and follow all Rockwell cautions and warnings in their maintenance manuals. Now, since some procedures require the use of special tools for safe and correct service, use them for your own safety and to prevent damage to vehicle components. We should also mention here that some advanced lube components have a label attached at the fill hole or door jamb by the OEM. It states that the component is filled with an approved extended drain lubricant. In an axle, the carrier or housing must always be filled to the bottom of the correct fill level plug hole with the specified oil. All Rockwell RT and RS series axles have their fill plugs located in the axle housing bowl. Other axle series, like the SQ100 and SQHD, will have more than one location for lube fill. These fill locations are determined by the angle of the input yoke. To locate the fill level hole, begin by establishing that your drive line is horizontal. Then measure the angle of the input yoke. If it's more than 7 degrees above the horizontal, use the hole located in the axle housing bowl. If the angle is less than 7 degrees above the horizontal, use the plug in the differential carrier. And we also want to note that if a vehicle has an air ride suspension, it must be inflated. Otherwise, your oil level reading will be incorrect. When you find the right plug, clean the surrounding area and remove the plug. The oil must be even with the bottom of the hole of the fill plug. If oil flows from the hole when the plug is loosened, the oil level is too high. Let the oil drain to the correct level. If the oil level is below the bottom of the hole of the fill plug, add the specified oil. Should a significant amount of oil be needed, further inspection of the component is necessary. Install and tighten the plug securely to 35 to 50 foot-pounds. Now remember at this point that some axle models have a small tapped and plugged hole near but below the housing lubricant level hole. This hole is for the temperature indicator only and must not be used as a fill or level hole. During the scheduled oil change for an axle or transmission, there are specific procedures to follow when draining and replacing the oil. When working on drive axles, make sure the vehicle is parked on a level surface. Block the wheels, take the key out of the ignition, and put a large container under the axle. If the truck has been operated, let the axle cool to room temperature. Clean around the drain and fill plugs. Then remove the drain plug from the bottom of the axle and drain the oil. Check the oil for debris, which might indicate a failure is occurring. Discard the oil according to EPA regulations. Now install and tighten the drain plug to 35 to 50 foot-pounds. If an oil pump is used, remove and replace the oil filter each time the oil is drained and replaced. When replacing oil, begin by removing the fill plug from the axle housing bowl or the differential carrier. Fill until the oil level is even with the bottom of the fill plug hole. Remember that if oil flows from the fill hole with the plug removed, the oil level is high. So let the oil drain to the correct level. Install and tighten the fill plug to 35 to 50 foot-pounds. If the axle has an interaxle differential with a top fill plug hole, put an additional 2 pints, 0.95 liters, of the same oil into the interaxle housing. And we recommend driving the vehicle unloaded for 1 or 2 miles, or 2 or 3 kilometers, just to circulate the oil thoroughly throughout the axle and carrier assembly. Let's talk about Rockwell's advanced lube axles. If the axle comes from the vehicle manufacturer with an approved synthetic lubricant, the requirement for an initial lubricant drop at 3,000 to 5,000 miles is eliminated. The on-highway change interval for these advanced lube axles is 250,000 miles. If the axle is equipped with an oil pump and filter, the same axle can clock 500,000 miles before a change. On these models, the oil filter must be replaced every 100,000 miles, and of course topped off with similar lube. All right, if the advanced lube axle model comes from the vehicle manufacturer with petroleum lube, no initial drop is required, but the change interval is 100,000 miles. Now, there are selected axle models that are not in the advanced lube program. These axles will require an initial 3,000 to 5,000 mile lube change. In all cases, if you have questions, be sure to refer to the lubrication manual for on or off highway oil change intervals. In our next segment, we'll turn our attention to Rockwell transmissions. You'll notice that some advanced lube transmissions have a tag on the fill hole that states if the transmission is filled with full synthetic oil. Since these tags are installed by the OEM, Rockwell cannot guarantee their availability. To check and adjust the oil level properly in a Rockwell transmission, park the vehicle on a level surface. If the vehicle has been running, wait 10 minutes before checking the oil level. The oil must be at room temperature. Clean the area around the fill plug and remove it from the side of the transmission. If oil flows from the hole when the plug is removed, the oil level was too high. Also, if you see a layer of foam on the oil is too hot to be checked. Let it continue to cool before checking. The oil must be even with the bottom of the fill plug hole. If the oil level is below the bottom of the hole of the fill plug, add the approved oil. Do not use axle lubricant or mix oils, and check the approved lube list for any cautions or warnings. Install and tighten the fill plug to 35 to 50 foot-pounds. Drive the vehicle until the transmission is warm. Then recheck the level. The oil change procedure for a transmission is similar to that of the rear drive axle, and that includes making sure you follow the same safety precautions. Make sure the vehicle is parked on a level surface and put a large container under the transmission. You can cover the container with a screen to see if the transmission had any damaging metal particles. With the transmission hot, remove the 2 drain plugs from the bottom of the transmission and drain the oil. After inspecting it for debris, discard the oil according to EPA regulations. Now, install the drain plugs, tightening them to 35 to 50 foot-pounds. And by the way, if you're installing a new or rebuilt transmission, drain the oil from the oil cooler by removing the lines, draining the oil, and then reinstalling the lines. All right, now remove the fill plug from the side of the transmission and add the approved oil until the level is even with the bottom of the fill plug hole. As you know, today's aerodynamic trucks and higher torque rise engines cause higher operating temperatures. Because of these temperatures, we want to caution you to not use axle lubricant in the transmission. The extreme pressure additives used in axle oils are damaging to transmissions, so always check the approved lube list. This is an extreme example of damage caused to this transmission by using axle GL5 oil at high temperatures. It plates out on components and can cause shifting problems. To finish our procedure, install the fill plug and tighten it to 35 to 50 foot-pounds. Now, drive the vehicle until the transmission is warm, then recheck the oil level again and add oil as necessary. Now remember, advanced lube transmissions using approved full synthetic oil eliminates the initial oil drain and can travel 250,000 miles or 400,000 kilometers before the first oil change. Should you have any questions on the procedures we've covered today, remember you can always reference Rockwell's Lubrication Maintenance Manual. It includes recommended oil and grease lubricants, their specifications, capacities, and scheduled changes for all Rockwell products. Recommended grease lubrication procedures are also presented in the Rockwell Component Maintenance videotape. As a matter of fact, Rockwell has a full line of maintenance manuals and videotapes. Just call your Rockwell representative at 1-800-535-5560. Our program today is one of a series of specially prepared programs on the maintenance procedures for Rockwell products. Thanks for watching. We'll see you next time.